Hi, I'm Sean Gannon, and this is MinuteMath, and today we're going to learn about how to identify the degree and leading coefficient of polynomials.
MinuteMath, when you need help you use MinuteMath.
One thing with polynomials is that you've probably seen them before, okay, in different forms. So for example, you'll see different ones, like a 5x to the fourth. If it was just this, we would call that a monomial. If we had, let's say, 2x minus 9, we call that a binomial. And let's say if we had negative 3x squared plus 8x minus 7, we call that a trinomial. Okay? So notice these are different types of polynomials, but where do we get this mono, 1, binomial being 2, and I spelled it right, yeah, and trinomial 3? Well, one term really here, 1. Here we have 2 separate parts, and we have 3 separate terms there. So trinomial. That's where the words come from. Okay. We can determine there also now the degree of a polynomial by identifying its highest power. Okay, its degree. So you actually will see something like this. Helps see the term written out here. So if we have, let's say, a sub n x to the nth power plus dot 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 plus a sub 2 x squared plus a sub 1 x, and it's going to be like to the first power, but again, x to the first power we don't write, and then a sub 0. These a values are what we call our leading coefficient. Okay. We have our degree right here, and our leading term, which will be this whole section here. All right, that whole a sub n x to the n power is our leading term. Okay. So what do we have here? If we notice, the degree is going to be the highest power in our polynomial, x to whatever the highest power is. That's going to be a degree. Our leading coefficient is the coefficient in front of that x value with the highest power. And then the whole thing together is what we call our leading term. Now, of course, we have this is when it's organized. It's going to be on the left here when we have the highest degree written first. Sometimes it might be jumbled within the polynomial, and we will have to find it. Notice now it's labeled sub n and nth degree, and as we go down, the numbers, basically this dot 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 is showing that it could go, infinitely high, essentially, but it keeps going down to our different values. Now, sometimes the number 0, let's say, might be a sub 2, and if that's the case, there would be no term here. Okay, and notice here, really, if this is x to the first power, we could have like x to the 0 power, which is 1 at the end, and then we're done. The degrees just kind of keep counting down. So, a little definition here for polynomials. A polynomial is an expression that can be written in the form as such right here. Ax sub n to the, or a n x to the nth power plus dot 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 plus a sub 2 x to the second power plus a sub 1 x to the first power, essentially, plus a sub 0. Each real number, a sub I, is called a coefficient. The number a sub 0 that is not multiplied by a variable is called a constant. Each product, a sub I x to the I power, is a term of a polynomial. The highest power of the variable that occurs in the polynomial is called the degree of the polynomial. The leading term is the term with the highest power, and its coefficient is called the leading coefficient. So essentially everything I've already kind of talked about, but there's your definition. Okay, so let's go identify some polynomials here. So let's go through an example here. Say I'm given this, 3 plus 2x squared minus 4x to the third power. Okay, so what's our highest power here we see? X to what power? Well, we have nothing really here but x squared and then x to the third. So since x to the third is our highest power, we'll say this has a degree 3. Degree is 3, okay? And so what's our leading term here? Our leading term, well, that's the whole part that has to deal with that highest degree. Since highest degree is 3, the leading term is everything beforehand. Now this is going to be tricky. We have the leading term is, and watch this, negative 4x to the third power. It's that whole thing. We have subtraction going on here, but we can always think of it as plus minus, or plus and negative, and that term here is at negative 4x to the third power. And so our leading coefficient is, can you guess it? Negative 4. Okay? That coefficient, that's right there in front. And that's it. Not too hard. So let's do a couple more. Be kind of easy to do. So let's go B right here. Hopefully I have some room. And we have 5t to the 5th power minus 2t to the 3rd plus 7t here. Okay? So what do we have? What's our, let's say, our degree? Well, the highest degree I see is a 5, right? So a 5 is the highest one that I see in the power, so degree is 5. The leading term, well, if the highest degree is 5, that leading term that goes with it is the whole package, which is 5, let me separate this out of here, 5t to the 5th power. And the leading coefficient is pretty easy, is just that positive 5 here. Okay, is our 5. It's the term that's in front of the variable with the highest degree. Okay, not too shabby. Let's do one more. 6p minus p to the 3rd power minus 2. Okay, so what is our highest exponent in sense to a variable? And that's going to be right here, that 3. So we have a degree 3 here. Our degree is 3, but degree 3, I'll just write it like that. I always get a little erasing here. The only problem is my 5s look like my s's. Okay, that's like that's a 5. My leading term is, the whole term there is a negative p to the 3rd power. Okay, and our leading coefficient is, well, just a negative 1. Now this is tricky, right? When we write p to the 3rd power, or the minus there, we don't write that 1, and that's always, it's known that there's a 1 there. So it's a minus 1 is our leading term, or sorry, leading coefficient, excuse me. Well, I hope you found this video informative and helpful, and if so, please hit the subscribe button down below, like this video, and comment and share it. And it helps make us helps YouTube understand what we're doing here and try to spread this video around so we can keep making more videos. So thanks for watching.
Minute Math. When you need help, you use Minute Math.